Hello everyone, let's start with the series Roadmap to Become Competitive Programmer 5 Star. So in this video I'll be explaining 26th problem and its problem name is Good Program. So it says in computing the collection of 4 bits is called a nibble. Got it? So chef defines a program as good if it takes exactly x nibbles of memory where x is a positive integer, not good otherwise. Given a program which takes n bits of memory, determine whether it is good or not. So input test they've given as first line will contain t number of test cases. So there are test cases, we should take care of that. So this will take care of all the test cases. The first and only line of each test case contain a single integer n. This n is basically the number of bits taken by the program. So we need to determine for each test case output good or not good in a single line. You may print each character. Okay, this is fine. So let's try to understand the example. Some of the examples they've given 4 test cases. First test case n is for 8, 17, 52 and 3. So let's try to understand. Let me take you to the board. So in first test case n given is 8. So basically what they're saying is we have a program which is taking n bits. Okay, and as you know, the what they're saying in computing the collection of 4 bits is called nibble. Okay, so in computing what they're saying 4 bits collection of 4 bits are called nibbles. So this is I'll denote bits by 0 1 0 something like that, 1 0 1 1 1 0 0 1 something like that. So these collections are called nibble. This is one nibble, this is other nibble, this is other nibble. So now they are saying there are totally of 8 bits, which means, let me remove this, which means if you count here 1 2 3 4 5 6 7 8, we have 8 nibbles. So I mean 8 bits. So how many nibbles you have? A collection of 4 bits are called one nibble. So one nibble here we have and one nibble here you have. So basically 2 nibbles you have. So if you see this 2 is an integer. So they are saying in question, saying chef defines a program as good if it takes exactly x nibbles of memory where x is a positive integer. As you are saying here, x is a positive integer, hence this program is good. When program will not be good? When this nibble will have some floating point value, basically let's say 2.75. After this point we are getting some value. So in that case it will be not a good program. So let me take that example also and explain you. In second case x given is n given is 17. So let's understand the second example where n given is 17, which is saying we have total of 17 bits in program. So let me take 1 0 1 0 1 1 1 1 1 0 0 1 1 0 0 1. How many? 4 4 4 16. One more let's take. So here they are saying we have a program which takes 17 bits. So if you see how many nibbles are there, one nibble, second nibble, third nibble, fourth nibble, and this one if you see it does not have exactly 4 bits. So in this case we can say it is not a good program. We can see clearly through our eyes in this case, but how do we solve using this n? So if you see 17 by 4, if you do, that will give answer as 4. Okay. In I mean normal division it will give 4.25. 16 1 will remain, so 1 means 25, correct. In normal it will give 4 5, but in program This is 14, 17 by 4, which will give you only integer. But how do we check if we have a decimal number also? After point we have some value. So if you do 17 modulo 4, that will give an answer as 1. So if you have after in modulo, if you have any value, so in that case that program is not good. In the previous it was 8. 8 by 4 gave you a value 2, but 8 modulo 4, if you would have done, you got 0. If this is 0, remainder is 0, so in this case it is a good program. But in this case, if you are getting a non-zero remainder value, then it is not a good program. I think pretty much you got. So clearly you can see it's a collection of nibble. We have 4 nibbles properly, but this one is not a nibble, so it is not a good program. So I think pretty much you got that. Let's try to code it up. So basically n is there, so we'll have to check if n modulo 4, it has some value. Either if you do modulo with 4, you will get value as 0, 1, 2 or 3. So if it is 0, then it is good, but if it has apart from 0 like 1, 2, 3, then it is not a good. So we need to write here not good. If n modulo 4 is having, let's say, 0 value, then it will come in else condition. In that case, we'll have to say this is a perfect good program. Let's try to run the code. It is correct, good, not good, good, not good, good, not good, good, not good. Let's try to submit the code. Yeah, it got accepted. So basically you understood, I think, how we approached what is nibble and what will happen if we have a remainder value non-zero. So in that case we'll have an extra bits, so that will not give a perfect nibble. So in that case we'll have to say it is not a good, or else if it has a perfect nibbles, x nibbles, then it is a good. So yeah, thank you guys for watching.